So to start off with, in simple terms, could you explain to us what your solution is trying to solve?
Absolutely. So FeX Energy was born 3 years ago out of a lab at McGill University that came up with a way of storing energy in iron. So it's a thermochemical energy storage methodology. And in simple terms, you rust and unrust iron. So what's special about that? Doesn't sound that special. There's iron in cars, there's iron in bridges, it rusts. But what people don't realize is that that rusting process actually releases heat. So it's an exothermic reaction. And you can harness that energy and you can use that. And so what iron does is it stores a lot of energy per unit volume. And that makes for a product that is very dense. It means it's easily deployable. That makes it really well fit for remote applications. It also means that it stores energy for very long durations. So that iron that stores energy in our system doesn't lose energy with time. And that makes it flexible to be paired with renewables, intermittent energy sources, and enable continuous energy that is reliable. The challenge is really not about generating electricity, which the sun does. It's about capturing it, turning it into a useful output, and then storing it when and where it's needed. And that's what storage does. That's what our technology does. Is picture a large solar array in a remote application capturing the sun's energy. And that sun doesn't always shine. So when the sun goes away, the community, for example, powered by the sun doesn't have power when the sun's not shining. But our system can store that energy and can release that energy.
My next question is, how does being a recipient of the Challenge Fund will accelerate skill, learning, or partnerships for you?
Having a grant like this is enabling our pilot project, which we're actively deploying now in Canada, to go just a little bit faster and to also have just a little bit more of a focus on remote communities that are under-resourced, underserved in Canada. Canada has 280 remote First Nations communities that are largely powered by diesel. The diesel that they use can cost $1 a kilowatt hour for power generation. And, we pay in civil on-grid areas, 10 cents or 15 cents or 5 cents a kilowatt hour. So, imagine your power bill went up by 10. That's the sort of level of difficulty that people suffer from in the world. So to really have a solution like ours addressing remote communities that wouldn't otherwise be served is really how this challenge is helping us, how the grant and the fund are helping us.
Amazing. Do you have any tips or tricks for those who are going to apply for the Challenge Fund this year?
I think the best serving advice that I can give is just be yourself, be authentic and true to what you stand for. If you have the conviction and the belief that what you're building will solve a problem that's worth solving, other people will latch on and resonate with that.
Thank you, Hayden. I couldn't agree more. It's very much what Palladium does in their day-to-day work as well, and also what we as Kaima are trying to do in the communities that we work with. So that's beautifully worded. Thank you so much.